Hello, this is Dr. Hanaa Assil, and this is paper 1 CR January 2021 in the IGCSE chemistry at Edexcel. Let's take a look at the questions and discuss the answers. So this first question says the box lists some substances, and he says choose substances from the box to answer these questions. Each substance may be used once, more than once, or not at all. Please remember that when you have choices like this, that sentence always applies unless otherwise stated. So each substance may be used once, more than once, or not at all. Some students, when they choose one of the answers, they cancel it out so they don't look at it again. That's not correct. So bear in mind that each of these may be used more than once. So the first question says, name a metallic element. Which of these is a metal? You should be able to tell that the one that's a metal is copper. Then he says, name a compound. Now, which of these is a compound? Again, this is very easy. You should realize that water or glucose could be a possible answer here. So if he says name a compound, he wants one. Name a mixture. Now, which of these is a mixture? Air. You should realize that air is a mixture of gases. The next question says, name an element that is a gas at room temperature. So which of these is an element that is a gas? Well, you have choices, either nitrogen or oxygen. Name an element that forms a basic oxide. I'm going to remind you again, which ones form basic oxides? You should realize these are metals that form basic oxides. So if he says an element that forms a basic oxide, he's looking for a metal. So that would be copper. You should realize that copper oxide is basic. Name two elements that are in the same group of the periodic table. Which of these is in the same group? If you look at oxygen and sulfur, remember that the group is the vertical one. So in the same group, that means they should be vertically together. So that is sulfur and oxygen. The question says a student does a chromatography experiment using ink 1, ink 2, and 3 known dyes, A, B, and C. The student uses water as the solvent. The diagram shows the chromatogram. Then deduce what conclusions can be made about the composition of ink 1. Let's take a look at ink 1. Where is ink 1? What can you tell about ink 1? First of all, you should realize that when the ink goes up and gives 3 spots, that means it has 3 components. Then, if you look at the spots and you find that the spots from ink 1 are the same height as any of the other spots, that means it contains that substance. So, from the chromatogram, you can tell that ink 1 gave 3 spots. That means it contains 3 dyes. Now, what are the 3 dyes? You have a spot the same height as A, you have another spot the same height as B, and you have the third spot. It is not the same height as A, B, or C. So it has A and B and an unknown dye. Give one conclusion that can be made about ink 2. Where is ink 2? Okay, ink 2 is a spot that remained on the baseline, and we said if the spot remains on the baseline, that means it is insoluble in water. That means it did not dissolve. Remember that chromatography separates substances based on their solubility in the solvent. So just how the student could change the experiment to find the composition of ink 2. Now, ink 2 was the one that did not go up. If I find that a spot did not go up in the solvent I'm using, I should use a different solvent. So maybe if I use ethanol instead of water, then that spot will go up and separate into different spots. And then he says, calculate the RF value of C. How do we calculate the RF value? You should remember that the RF value is the distance from the baseline to the spot divided by the distance from the baseline to the solvent front, where the solvent went up to. So RF value, if he says what is definition of RF value, you should realize it is distance traveled by spot over distance traveled by solvent. In this case, it comes out to be 0.6. Remember that if you do the RF value correctly, it has to be something less than 1. So if he says he found that the RF value is 1 point something or above 1, that is wrong. It has to be 0 point something. The third question says crude oil is a mixture of organic compounds. Most of these compounds are members of the same homologous series. State the name of this homologous series. Okay, if we do a separation of crude oil or petroleum, most of the substances that come out are alkanes. So you have to remember that crude oil is a mixture of alkanes, or in general, a mixture of hydrocarbons. An industrial process is used to separate crude oil into fractions. You should remember that that industrial process is fractional distillation. In order to separate crude oil, we do fractional distillation. Now, the process depends on a difference in property of the fractions. What is this property? You should realize that fractional distillation separates a mixture of liquids based on difference in boiling point. The boxes give some uses of fractions and some names of fractions. Draw one straight line from each use to its correct fraction. Remember that when we do fractional distillation of crude oil, you are required to know the order in which they come out and the uses of each one. Here he's talking about uses. So which one is used as fuel for airplanes? You should remember that. Kerosene is used as fuel for airplanes. Fuel oil is used as fuel for ships. And making roads, we use bitumen. Please remember these uses. So he's saying fuels obtained from the fractions may contain impurities. Explain how the combustion of a common impurity in fuels may cause an environmental problem. Remember that most of these fuels have sulfur impurities. The sulfur impurity, when the fossil fuel is burnt, the sulfur becomes sulfur dioxide gas. This dissolves in rainwater to form acid rain. And then you have to mention some of the effects of acid rain. For example, it kills plants, it kills marine animals, it dissolves buildings. Some of the fractions contain long chain molecules which are not very useful. Give the name of the process used to convert long chain molecules into more useful shorter chains. What was the name of the reaction in which we break down long chain molecules into shorter chains? You should realize that is cracking. Now he says give the catalyst and temperature used in cracking. What was the catalyst for cracking? Remember that we said in organic there are some reactions that you have to know their conditions. For cracking, the catalyst was aluminium oxide catalyst, or we call it alumina. The temperature for cracking, 600 to 700 degrees Celsius. Then he says when C13H28 is used in this process, so we're still talking about cracking, 3 different molecules are formed. Please read the instructions carefully. He's saying 3 different. Now complete the equation for this reaction. You remember that when we're doing cracking, the total number of carbons before the arrow should be equal to the total number of carbons after the arrow, and the same for hydrogen. So before the arrow, we have 13 carbons. That means after the arrow, I want a total of 13 carbons. Now he already has 8. So I am left with how much? I should have 5 carbons. How do I divide the 5 carbons so that they are different molecules? So one of them will have 3 carbons, the other will have 2. And remember that these are alkenes. The total number of hydrogens after the arrow also has to be 28. So I have 18. I need a total of 10. That means if it is C3, it has to be H6. If it is C2, it has to be H4. Remember that the general formula for alkenes was CnH 2n. That means the number of hydrogen should be twice the number of carbon. When iron is left in damp air, rust forms. What is the chemical name for rust? What is rust? It is hydrated iron 3 oxide. It's very important to mention the 3. Iron 3 oxide. Now, explain how a barrier method prevents rusting. Remember that. Some of the methods of preventing rusting are based on being a barrier method. That means you cover the iron with something. Or we have things like galvanizing or sacrificial protection. So the barrier method is when you coat it with something. So iron is coated with paint or plastic or oil to prevent its reaction with water and oxygen. A student uses this apparatus to find the approximate percentage by volume of oxygen in air. So he has an glass tube and he has damp iron wool on the top. And originally we had all the glass tube filled with air. So he placed a graduated glass tube in a beaker of water, placed some damp iron wool and a rubber bung in the top, record the reading of the water level in the tube. Now remember that when we do this kind of experiment, we leave it for a few days. Remember, rusting takes about 5 days. Then what happens is the iron is going to rust. That means it is going to use up the oxygen in the air in the tube. And when that happens, the water goes up the tube to replace the oxygen that has been used in rusting. So first he says read the start and the end. Okay, the reading at the start is 20. The reading at the end is what? You know how to read these tubes? It is 30 something, so this is 33.5. Remember, if he has one of them with a decimal, then all of them should be with 1 decimal place. And he says you should give all your values to the nearest 0.5. That means you need 1 decimal place. Now, the volume of oxygen is the difference between them. The difference between them is 13.0, not just 13. He wants it to 1 decimal place. The student uses these results to calculate the percentage by volume of oxygen in air. Suggest why her calculated value is lower than the expected value. Well, let's see. If it is lower, that means she did not leave it long enough, and that means it did not use up all the oxygen that reacted. The student repeats the experiment. These are her results. So he gives me the results and he says, use these results to calculate the percentage by volume of oxygen. He says, the air in the tube at the beginning was 80. The reading at the start was 20. And the reading at the end was 35.5. So if we start with 80, then I have the reading 20. It went up to 35.5. The difference is the amount of oxygen. So the difference is the amount of oxygen. The percentage would be that amount over the total amount of air times 100. A student uses this apparatus to investigate the effect of heat on different solid metal carbonates. So she uses a spatula to put some metal carbonate in the boiling tube, fit the delivery tube into position, pour some lime water into the test tube, start a timer, immediately begin to heat the metal carbonate, record the time when a change first occurs in lime water. So she's heating the metal carbonate. It should break down to give carbon dioxide gas. The carbon dioxide gas goes into the lime water, makes it milky, and that's when she stops the time. State the name given to this type of reaction. When I heat something and break it up, this is thermal decomposition. State 2 variables that the student should control in this investigation. She wants, what are we trying to do? She wants to change the type of carbonate, so she has to keep everything else the same. So the same mass of the carbonate, the same volume of lime water. Suggest why bubbles appear in the lime water after heating has started. but before there is any change. So the metal carbonate has not decomposed yet, and yet you will see bubbles in the lime water. Where did these bubbles come from? They are from the air that was in the boiling tube. You remember the boiling tube originally had air without any gas coming out. So when you heat it, the air expands and the air bubbles into the lime water. Explain the purpose of the lime water. Of course, the lime water detects the presence of carbon dioxide to show that the carbonate has reacted. The table shows some of the results for the student's investigation, and he's saying state the color change that occurs for copper carbonate. Please remember the colors that we're supposed to know. For example, copper carbonate, you should know, is green. When you heat it, it turns to copper oxide, and copper oxide is black. Give a chemical equation for this reaction. So copper carbonate breaks down to give copper oxide plus carbon dioxide. Please, when you write the chemical equation, first of all, it has to be simple. Secondly, you have to check that it is balanced. In this case, this one is balanced. We don't have to do anything to it. There is a relationship between the position of a metal in the reactivity series and how easily the metal carbonate reacts. Use the student's results, so the student's results are these, and your knowledge of the reactivity series, for example, to determine this relationship. Okay, let's see. Remember that if something takes a longer time, that means it is a slower reaction. So, for example, calcium carbonate took 90 seconds, sodium carbonate did not change at all, copper carbonate took 50 seconds. Now, if we look at these metals in the reactivity series, you will realize that sodium is a very reactive metal. It did not break down. Calcium is also reactive metal, less reactive than sodium, but it's also reactive. It took a long time to break down. Now, copper is much less reactive. It took less time. So that means that the less reactive the metal, the more easily the carbonate decomposes. State how you should extend the investigation to see if your deduction is correct. Remember that he did this on only 3 metal carbonates. If I want to say that this is the general trend, then I should repeat using many other metal carbonates to see if my deduction is correct or wrong. Zinc reacts with dilute hydrochloric acid to form hydrogen. Give a chemical equation. Again, please practice writing these equations. Remember that zinc, the valency is 2, so it is ZnCl2. Hydrogen is diatomic, it has to be H2. And then to balance, I have to put a 2 in front of the HCl. Please practice all of these kinds of equations. Give a test for hydrogen gas. What was the test for hydrogen gas? We said insert a lighted splint, it pops. That's the test for hydrogen gas. A student investigates the reaction between pieces of zinc and dilute acid. In each experiment, he uses the same mass of zinc but different volume of acid. He collects the hydrogen, measures its volume, and this is the graph. He says, use the graph to find the minimum volume of acid needed to react with all of the zinc. How do I know that? Remember that as I added more volume, I got more volume of acid, I got more volume of hydrogen, and so on, until all the zinc has reacted. So when all the zinc has reacted, even if you add more HCl, you don't get any more gas. So when did all the zinc react? When there is no more increase in the volume of hydrogen gas. So that is from the graph, that is at about 52 centimeter cubed. Remember, he's looking for the volume of acid, so you're looking down. Where is the volume of acid? It is 52 centimeter cubed. Please, if he does not write the units, you are required to write the units. The student repeats the investigation using hydrochloric acid of double the concentration. Now, determine the volume of hydrogen that would be collected using 15 centimeter cubed of this acid. So he's using a more concentrated acid That means if I look at the graph, I get what? I get 34 when he's using the normal concentration that he was using. If he uses twice or double the concentration, then he should have twice the volume of gas. So instead of 34 that we get from the graph, it should be 68 centimeter cube. Do you understand that? The graph is for a certain concentration of hydrochloric acid. If he uses that concentration, he should get 34 of hydrogen. But then he says he's using double the concentration, then he should get double the amount of hydrogen. Explain how increasing the concentration affects the rate. Please read each question very carefully. I find that most of the mistakes made by many students is that they did not read the question from the beginning to the end. Explain how increasing the concentration of hydrochloric acid affects the rate. If I increase the concentration, why? What happens first to the rate and why? Now, you should realize if I increase concentration, the rate increases. So that's one mark. Don't forget to tell him what is the effect on the rate. The effect on the rate is that it increases. Then explain why. This is because there will be more particles in the same volume, so more successful collisions per minute. You have to mention the time factor. The rate of reaction could also be affected by changing the temperature or by using catalysts. Explain one other way in which the rate between zinc and hydrochloric acid can be affected. So he already mentioned temperature, concentration, and catalyst. What else can we do? Remember, it is increasing the surface area. Instead of using a big piece of zinc, I use small pieces of zinc. So using powdered zinc, for example, instead of lumps, increases the surface area, more particles collide at the same time, and this increases the rate. The formation of ions and covalent bonds involves electrons. Describe the different roles of electrons in the formation of lithium chloride and hydrogen chloride. Now, what happens when lithium reacts with chlorine to form lithium chloride? You should realize that lithium is a metal. It has 1 electron in its outermost shell. Chlorine is a non-metal. It has 7 electrons in its outermost shell. That means we're doing an ionic bond. What happens is the lithium atom loses 1 electron from its outer shell to form lithium Li+, while chlorine atoms gain 1 electron to form Cl-. The other one, hydrogen chloride is covalent. This is because hydrogen and chlorine are nonmetals. Remember that hydrogen chloride as a gas is covalent. What happens is the hydrogen and the chlorine atoms share a pair of electrons. So chlorine has 7, it needs 1. The hydrogen has 1 and it needs 1. Remember that for the hydrogen, this is the first energy level, so it needs a total of 2. So they share 1 pair of electrons to form 1 covalent bond. Explain why lithium chloride has a higher melting point than hydrogen chloride. Okay, remember we said lithium chloride is ionic. And ionic means it is a giant crystal lattice with alternating positive and negative ions. So it will have strong attraction forces between positive and negative ions in the giant crystal lattice. This needs a lot of energy to be broken. For hydrogen chloride is just a simple molecular structure with weak attraction forces between molecules that needs less energy to be broken. Explain what is meant by the term isomers. Remember, definitions are very important and they are the easiest questions you can get. Isomers are compounds having the same molecular formula but different structures. Do not confuse them with isotopes. We have something called isotopes and something called isomers. Organic compound Q reacts with bromine without the presence of UV light to form the compound C4H8Br2. Now, that tells me that you're adding to the molecule, adding two bromines. You don't need UV light. That means Q is not an alkane, it is an alkene, and it is an alkene with 4 carbons. So I can draw two isomers. What are the two isomers of butene? Butene can have the double bond after the first carbon or the double bond after the second carbon. I'm reminding you again that each carbon cannot have more than 4 bonds. So do not add any extra bonds with extra hydrogens if the carbon already has a total of 4 bonds. An acrylic polymer can be formed from molecules with this structure. A student describes the molecule as an unsaturated hydrocarbon. Explain whether this is correct. Well, let's see. What does unsaturated mean? Unsaturated means it has a C double bond C. So this is correct. It is unsaturated. But then, is it a hydrocarbon? Remember, hydrocarbon means it has carbon and hydrogen only. So this is not a hydrocarbon. You can say it's not a hydrocarbon because it has oxygen in addition to carbon and hydrogen, or because it doesn't have carbon and hydrogen only. Name the type of polymerization that occurs in the formation of the polymer. Remember, if I'm starting with an alkene, what is the type of polymerization? Addition polymerization. Starting with alkenes, the polymerization is addition polymerization. Complete the equation for the polymerization reaction. Again, if he gives me an alkene and he says draw the polymer, how do I do that? I remove the double bond, put single bonds on both sides, close it with a bracket and write an N to indicate that this is repeated many times, and then you just copy what each carbon was originally bonded to. So that first carbon was bonded to H and H, you copy that. Now the second carbon on the other side of the double bond was bonded to a CH3 and COOCH3, you just copy it. Okay, so that is the structure of the polymer. Octane is a compound in petrol. The equation for complete combustion of octane is this. The fuel tank of a car contains 50 decimeter cubed of octane. So this is my volume of octane. Calculate the mass in kilogram of carbon dioxide formed if all the octane undergoes complete combustion. So this is basically normal calculation. We're starting with a certain volume of octane, and he says the mass of 1 decimeter cubed is 700 grams. So I can get the mass of the octane. So the mass of the octane is the 50 times 700. So this is the mass of octane I have. Then, in order to continue, I have to get the number of moles. So number of moles of octane, you should remember, is mass over molecular mass. So the mass that we got over the MR of octane, it is C8H18. You should be able to calculate its MR. That gives me a certain number of moles. Then, after we get the number of moles of what he gives me, I should look at the equation related to what he's asking about. What is he asking about? He's asking about carbon dioxide. I look at the equation. The equation tells me 1 mole of C8H18 will give 8 moles of CO2. So I can get the number of moles of CO2. It will be this number of moles times 8. And that means I can get the mass. Mass is number of moles times the MR of CO2, and that is the mass. Then he says, state an environmental problem caused by carbon dioxide. Carbon dioxide gas is one of the greenhouse gases. It causes global warming. Remember that. Carbon dioxide and methane help to trap the heat around the earth. So this causes rise in the temperature of the earth. This is what we call a greenhouse effect or global warming. Remember, carbon dioxide does not cause acid rain. Please do not say acid rain. Acid rain is caused by sulfur dioxide or nitrogen dioxide. Carbon dioxide does not cause acid rain, it causes global warming. Lithium, sodium, and potassium are the first three elements in group 1. Suggest why these three elements are all stored in paraffin oil. Remember that group 1 in general are very reactive metals, so we store them in paraffin oil to prevent it from reacting with oxygen and water in the air. Now, cesium is below potassium. Give a similarity and a difference between the reactions of potassium with water and cesium with water. You should know which of these is more reactive. It is the cesium. So both of them, because they're in group 1, both of them will float, dart, melt, both of them would form bubbles of gas, but the difference is cesium is more vigorous and it may explode. Give the chemical equation for reaction with cesium and water. Remember that any group 1 metal reacts with cold water to form the hydroxide. So cesium plus water will form cesium hydroxide plus hydrogen. Again, do not forget to balance the equation. A student investigates the temperature change in the reaction between dilute acids and solutions of group 1. This is the student's method. Measure the temperatures of 50 centimeter cubed of hydrochloric acid. Pour the acid into a polystyrene cup. Remember, we said we usually, any reaction that involves measuring temperature, we should do it in a polystyrene cup because it is an insulator and prevents loss of heat to the environment. Add 50 centimeter cubed of sodium hydroxide solution. Measure the maximum temperature. Now, suggest what could be added to the apparatus to improve the experiment. Actually, this apparatus is missing something. When you use a polystyrene cup, you should actually cover it with a lid. Otherwise, there will be loss of heat to the surroundings. Explain a change to the method that would improve the accuracy. Okay, when he says explain a change to the method, you should stir the solution to distribute the heat evenly so that when you measure the temperature, it is the correct temperature. These are the students' results. Calculate Q. Again, we said if we have this, what is Q? He said we needed measure the temperature of 50 centimeter cubed of hydrochloric acid. Pour the acid and then add 50 centimeter cubed of sodium hydroxide. Remember, Q is MC delta T. So what is M in this reaction? M is the total volume of the solution, because we said we're assuming the density of the solution is 1, so the volume is the same as the mass. M is the mass of solution, so I have a total of 100 centimeter cubed. That means my M is 100 times 4.2 times the temperature change, and that gives me the Q in joules. In the student's reaction between hydrochloric acid and sodium hydroxide, he used 0.05 mole or 0.05 mole of water was formed. So the delta H is the Q over the number of moles. This gives you in joules. If you want it in kilojoules, divide by 1,000. You have to remember that the delta H must have a sign. And the sign will be indicated by what? Because there was a temperature rise, then my sign is negative. The temperature rise means exothermic reaction, means my delta H must have a negative sign. This question is about salts. Soluble salts can be prepared by the reaction between a metal oxide and an acid. State the name given to this type of reaction, where we have metal oxide, we said, is a base. React with acid to give salt plus water. This type of reaction is neutralization reaction. State in terms of protons what happens in this reaction. When I have an acid reacting with a base, the acid is a proton donor, so we say the acid donates a proton. The base is a proton acceptor. A student is given 50 centimeter cubed of dilute sulfuric acid and a bottle of solid copper carbonate. Describe the method that the student should use to prepare a solution of saturated solution of copper sulfate. So first of all, he doesn't want crystals. So take care that he's not looking for final pure dry crystals. He's just looking for a saturated solution. So how do we do this? We're starting with solid copper carbonate. So we're supposed to explain the method that was called neutralization method. So how do we do that? We put the solid copper carbonate on the acid in a beaker using a spatula. Then we stir with a glass rod until excess solid remains, and then filter. We filter to get rid of the excess solid. Then we heat the filtrate to point of crystallization. Now, he wants it to be a saturated solution. So once I heat it to point of crystallization, this is a saturated solution. I filter it. What the filtrate is what we want. The student produces dry crystals of hydrated copper sulfate from the saturated solution. Of course, we said if I keep the saturated solution to cool, then it will form crystals. He calculates that 6.4 grams of crystals should be formed. Now, the mass of crystals he actually obtains is what? 1.8 grams less than he calculated. Many students would just write 1.8. It's not 1.8 that he got. He got 1.8 less than he calculated. He calculated that he should get 6.4. So what he actually got is the 6.4 minus the 1.8 over the total times 100. That is how we get percent yield. Gypsum is hydrated calcium sulfate. A sample of gypsum contains 79% of calcium sulfate. Calculate the value of X. Again, this is a typical question. Please pay attention. We're doing it as if we're doing a determination of empirical formula. So he says, I have 79% calcium sulfate. That means the rest is water, the rest of the 100. So 100 minus 79, that comes out to be 21% of water. How do we determine empirical formula? First, we divide by the molecular mass of each one, and he already gives me the molecular mass. Now, the numbers that come out, I have to divide by the smallest to get a simple ratio, and this means that my X is 2. Calcium sulfate, 2 water. Describe a test for calcium ions. What was the test for calcium ions that we have? Add aqueous sodium hydroxide. It gives a white precipitate insoluble in excess. And that is the end of the paper. I hope this helped you to revise. Thank you for listening.